In the Qualitative Analysis lab, you will obtain an aqueous solution with an unknown ionic compound, and you will identify the unknown cation and the unknown anion in that solution. The unknown cation could be calcium, iron, or ammonium, and the unknown anion could be chloride, sulfate, carbonate, or phosphate. To identify an unknown ion, we work with selected reactions that produce observable physical change. That could be formation of a gas, color change, or the formation of a precipitate. To produce as little chemical waste as possible, we carry these reactions out on a spot plate. For each test, we use one of the rows of the 3 depressions or spots. In this example, we test for carbonate ions. We fill the first spot with a few drops of distilled water. The second spot will be filled with a few drops of the unknown ionic compound, and the third spot will be filled with a few drops of a solution that we know contains carbonate ions. This is how it looks like when all 3 spots are filled, and they should contain all the same amount of liquid. And it looks like somebody has filled a little bit too much of the solution known to contain carbonate ions here in the third spot. We now add 3 drops of nitric acid to each of the 3 spots. If any of these liquids contains carbonate ions, which we know is the case in the third spot, then the carbonate ions will react with the nitric acid to form carbon dioxide gas bubbles. Should our unknown contain carbonate ions as well, we should also be able to observe the formation of gas bubbles. Our distilled water is the blind test just to make sure we work cleanly, and we shouldn't see any gas formation when we add nitric acid to the distilled water. Here you can see the formation of the carbon dioxide bubbles as a result of the reaction between carbonate and the acid. In this example, adding acid to the distilled water and to the unknown solution does not result in the formation of carbon dioxide bubbles, which allows to conclude that the unknown does not contain carbonate. Here's another test carried out in the second row of the spot plate for chloride ions. We have distilled water, our unknown solution, and a solution known to contain chloride ions prepared. When the chloride ions are combined with silver ions, they form a precipitate. Silver chloride is insoluble in water. The source of our silver ions is silver nitrate solution. Here you can see what happened after we added a few drops of silver nitrate solution. The solution known to contain chloride ions, of course, precipitated the silver chloride, and our unknown shows the same result. A white precipitate has formed, which is indicating that our unknown does indeed contain chloride ions as well. The distilled water, as expected, does not show any reaction, as it does not contain any ions. These tests are only reliable if we add equivalent amounts of liquid to each spot. In this example, when you compare the amount of liquid in the distilled water spot to the spot with the unknown solution, you can see that someone has not done a very good job at adding equivalent amounts of liquid to the 2 spots. As you can see from the marking rubric, the lab data sheet is very important for this lab. You should create an observation table for each ion test before you come to the lab. Check the lab manual for an example. Your observation table should have a row for each procedure step and a column for each of the liquids. In the resulting fields, you will enter concise descriptions of your observations. Under each of the 7 observation tables, leave room for a conclusion statement. This statement has 2 parts. First, you describe what a positive test would look like, and secondly, you describe which observation allowed you to conclude that the tested ion was present or not present in the unknown solution.